A unit operation can be defined as any step of a multi-step process that is considered to have one function. A unit operation is crucial in many physical and chemical processes. The first step is usually raw materials, and a physical or chemical change usually occurs with a unit operation. For example, polymerization, crystallization, or evaporation. In chemical engineering, there are 5 main categories of unit operations. These include fluid flow, heat transfer, mass transfer, thermodynamic processes, mechanical processes. Also, combination, separation, and reaction are other unit operations that are part of more than one category. There are many examples of unit operations across the Uconn campus. These include, but are not limited to, the pasteurization of milk at the dairy bar and on Uconn farms, refrigerators found in dorm rooms as well as dining halls, cafes in the Union, microwaves, every laundry room on campus with dryers, the combustion turbine in the cogen power plant, and the filtration that occurs in the water reclaim facility. The first unit operation I will be focusing on is the drying that occurs in the laundry room of my dorm, NextGen. This unit operation of drying solid materials is one of the most common and important processes. Drying occurs when water and other liquids are vaporized to form a dry solid. It occurs by supplying heat into direct contact via convection, indirect conduction, radiation, or microwave drying. Heat transfer and mass transfer are very important in drying. This is because in a dryer, heat is transferred to the clothes to evaporate the water from them, and then mass is transported out of the clothes as vapor. As the clothes move around in the rotating tumbler in the dryer, heat is pumped in and drawn through the clothes. The heat has caused the water to evaporate, and then the hot water leaves out the exhaust vent in the form of steam. Refrigeration is the next unit operation found at Uconn in the dorms of many. Refrigeration is a thermodynamic process because the system passes from an initial to final state of thermodynamic equilibrium. It starts with the compressor, raising pressure and pushing it into the coils on the outside. The hot gas and the cooler air temperature cause it to become a liquid. The high-pressure liquid causes the refrigerant to cool down as it flows through the coils into the freezer and fridge. The refrigerant then absorbs the heat, cooling the air down in the fridge, and then evaporates into a gas into the compressor, starting the cycle over once again. The final unit operation is the combustion turbine in the cogen power plant. The combustion turbine works as following. Air is drawn into the engine through a compressor. It is pressurized and then goes into the combustion chamber. From there, the natural gas expands the air and causes the turbine blades to begin turning. The turbine provides electricity to a generator that powers all of Uconn's campus.